Use the linearity of the Laplace transform to find the Laplace transform of sine squared of t. Some tables of Laplace transforms may include the transformation of sine squared, but ours does not. It does, however, have the transformations of sine of omega t and cosine of omega t. So if we can rewrite sine squared of t in terms of sines and cosines, then we can use the table along with the linearity property of the Laplace transform to find the transformation of sine squared of t. From trig, sine squared of t is equal to 1 minus the cosine of 2t all over 2, which we can rewrite as 1/2 minus 1/2 cosine of 2t. Then, since the Laplace transform is linear, the Laplace transform of sine squared is the Laplace transform of 1/2 minus 1/2 cosine of 2t, which equals the Laplace transform of 1/2 minus 1/2 the Laplace transform of cosine of 2t. Now we know from both the tables and a previous example that the Laplace transform of a constant c is just c over s. So L of 1/2 is 1/2 over s, which is 1 over 2s. And we can use that the table says that the Laplace transform of cosine of omega t is s over s squared plus omega squared to write that the Laplace transform of cosine of 2t is s over s squared plus 2 squared, which equals s over s squared plus 4. So plugging these in, we get that the Laplace transform of sine squared is 1 over 2s minus 1/2 s over s squared plus 4, or 1 over 2s minus s over 2s squared plus 8. Or if you prefer, you can get a common denominator and simplify.